One of the many important consequences of technology moving as fast as it's been is it's calling many fundamental assumptions to the mat. Not the least of these is business defensibility. What was defensible a few years ago, now clearly no longer is not. Software alone is not the moat it once was. This makes the question of competitive moats more important than ever, and that's what we're going to explore today. For those in the SaaS business, things have been looking pretty rough lately. Some of the most successful SaaS companies, just in the last few weeks, are beginning to fold. And some of the most sophisticated and longtime proponents of SaaS are making some pretty grim predictions about the fact that we're perhaps just getting started. So what are we really talking about here? We're talking about a spectrum of futures where, on one hand, there's the risk that your customer or potential customer will build an application using AI that obviates the need for your product. While on the other hand, there's the risk that a larger SaaS company will featureize your product using AI and then use their distribution advantage to also obviate your product. Stuck between these two extremes is a pretty hard place to be unless you can find some way for AI to become your competitive edge. Or as it were, turn lemon into lemonade. And now is a better time than any to revisit your moat. So things that, whatever your previous moat was, best to throw that all out and revisit and make sure that you don't have, as in the case with this castle about to be boarded by these alien troll invaders, that you're not leaving any gaps open. About a year ago, I spoke at the SaaSer conference and spoke about the moat specifically from the perspective of a software company. And I feel like these have largely held up. The sources of durable competitive advantage for software companies include if you have valuable and proprietary data that no one else has, taking advantage of peer community and other kinds of community network effects, having world-class domain understanding that's paired with and used to develop a user experience that users fall in love with. Now, this may not work in terms of companies that are your buyers who are using AI to build out their core business capability, but there are all kinds of capabilities inside of a business which companies just need to do to get along. And giving them an amazing experience that works way better than anything they could have built that's well thought through is really what these last two are talking about. And then there's the obvious litmus test. Anything that can be easily built in an afternoon with AI is just simply not going to work. But let's broaden this and look beyond just SaaS. So here we are in 2026, and AI is disrupting and has the potential to disrupt every single industry. And if I look at what the single biggest uniform competitive differentiator is across all industries, I have to come back to data. Now, when we talk about agents, we talk about how we want the agents to behave, but everything in AI fundamentally comes back to what data was used to train the model, to work alongside the model, to provide context. Everything fundamentally is about data. Now with data, for all of you who have worked with it, you know that there's signal, but there's also a lot of noise. So it can be very tempting to say, hey, AI is really good at making sense of things. How about I just throw it all the context and then let it make better decisions based on just sending it all the reams of data? And it turns out, unfortunately, because that would sure be convenient, that that's a misconception. This person, Akash Gupta, did a meta-study last August looking at 1,500 papers that had been written around the use of context for prompt engineering, and found that the most common myth and missed expectation and disappointment when doing prompt engineering is that the longer the prompt, actually the worse the result is, not the better. And then as a byproduct, it's also much more expensive and much slower, and you need to use larger models when you're just stuffing your context with all kinds of stuff. And there have been some antidotes to this. And in the early days, an antidote was, let's use a vector similarity computation, looking at language. And about 2 years ago, I wrote this piece that called the GraphRAG Manifesto that describes another pattern that's become increasingly popular, especially coming into this year, where you take data that shows up in the real world as a graph, as a network, as a hierarchy, as a path, and then use that to selectively choose what are the things that are important in the context of the part of the real or digital world that I'm dealing with, and let's just send those back to my model. So I included a link here in case you want to look it up, but if you just search for GraphRAG Manifesto, it's pretty easy to find. This is a technical but fairly accessible piece. And then coming into this year, you had this whole buzz around context graphs, and specifically this post, which probably many of you have already seen, from Jaya Gupta and Ashu Garg at Foundation Capital, saying that the next trillion-dollar opportunity in AI is going to be entirely based on context graphs. Now, they use this term in a very specific way, and it turns out that this is one of many kinds of graphs, all of which provide an opportunity for competitive differentiation. What they're talking about here is decision traces, and in a world where you have many business processes that are documented, but many that are not, or some that are documented, but maybe the real world diverges from the document, you can take all your business decision traces, which are effectively paths which can be modeled as a graph, stack those up, and agentify processes that are not clearly documented and where the process varies. And Gartner, just in the last few weeks, have published a new hype cycle for agentic AI that puts context graphs on the rise, pretty high up already. And something that was surprising to me as a technologist is I'm used to buzz around various AI data circles talking about various technology trends, agents, graphs. But there was this incredible blog post that came out in February written by Mike Hsu, who is served as comptroller of the currency during the Biden administration. This is a presidential appointee who's responsible for regulating US banks. And he makes this statement. Says, this post argues that supervisors should learn the language of knowledge graphs, i.e. nodes and edges, or I prefer the term relationships, to see the world distinct from rows and columns that have shaped our understanding of the financial system. And he has a few pictures here. And he refers to this hypothesis called the Sapir-Whorf hypothesis, which describes the fact that the language that you speak influences the way you see the world, and he speaks to that in the context of data. Anyone recognize this? Can anyone call out what movie this is from? The Arrival. He actually uses The Arrival as a metaphor for seeing data differently, which causes you to see the world differently. In this movie, this is an example of the way aliens speak and express their language. And I'll try not to spoil it, but a big part of this discovery journey in the movie is understanding how humans and aliens communicate differently, bringing in a linguist and closing that gap. And so what I would postulate is actually the same thing as Mike, which is that once you take your existing data and start to view it as a graph, not only is that a new technological enablement that can be used to cause business differentiation, but it's a change in mindset and a change in worldview that can unlock entirely new possibilities. And let me give a few examples. So we're talking about trillion-dollar opportunity in terms of context graphs. I'm going to tell you the story of a trillion-dollar company built entirely on graphs, and that's Google. When they first started, there were around 30 other startups at the time that were all indexing the World Wide Web and retrieving results just based on a text search. And that was pretty innovative at the time. And when Google came out, they did one thing, this is pulled out of their press release, that was different from the others, is that the way in which they ranked the vectors was based on one graph algorithm, which is a centrality algorithm called PageRank, which basically says I'm going to rank not based on the frequency of text, which can be gamed, but the number of inbound relationships to each web page, and then let's do that recursively just for good measure, and weight your inbound relationships based on the number of inbound relationships for the page coming in. This caused Google to catapult above everybody else in their industry. Up until 12 years later, they disrupted themselves with another graph concept and graph construction called the knowledge graph. Because what PageRank doesn't do is it doesn't tell you anything about what the data is. So the knowledge graph allows me to disambiguate if someone is searching for Rio, or they're looking for a hotel, casino, a city, or a movie. And the knowledge graph allowed Google to disrupt themselves. That lasted about a decade, and now they use it together with LLMs, and they are actually one of the early adopters of GraphRAG. Here's an example from the Google I/O keynote where you have this incredibly complex and personalized question. And the way they described addressing that answer was not just feed it to a model, but let's do a call out to the context graph that comes out of information from Gmail and any relationship extraction, pull data out of Google's knowledge graph, and then feed it to the model and get a better answer. So taking a graph view unlocks this step function in value. And what we're seeing and what I just described at Google is something that I've seen in my 14-year journey working at Neo4j and working with graphs, which is that if you take a traditional perspective, this is maybe the human view on data, and then you take the graph perspective, let's call that the alien view to use Mike Shu's Arrival analogy, then you unlock this massive new opportunity. Now, Google's an older example. Let's look at a newer company. This company, JupiterOne, has a core business, which is cybersecurity, and cybersecurity includes understanding the network of all the devices inside of a company, the hierarchies of users and roles, and then tying those together to do risk analysis. So they're a unicorn, so they're a billion-dollar case study, not yet a trillion-dollar case study. And something that they observed is, from a technological perspective, once they understood their core data set to be a graph, they were able to achieve these incredible technical gains where everything is 1 to 2 orders of magnitude faster, which unlocks new business opportunity. Like this example of being able to view assets, context, and risk for blast radius detection. And there are all kinds of examples. Arvin from Glean is speaking here. They use a knowledge graph. Palantir, of course, with their ontologies. And then a number of journals and analysts are just calling this out as a big AI trend. Which brings us to the question, what's your graph play? So first and foremost, let's identify what your graph is. And this invariably is going to be data that naturally shows up in the real or digital world as a network. Computers, social, communications, biology, ecology are all networks. Or as a hierarchy, supply chain, bill of materials, HR, or as a path or journey through one of those. And there are a number of different graphs that show up in AI. The examples I gave on the previous slide are all domain graphs, which is your digital twin of your real or digital world. You also have your graphs of meaning and terminology, as well as your mapping of how data flows throughout an organization, and mappings from your physical to your logical definitions. The term ontology and semantics are typically used in this world. There's a lexical graph, which you'll see I refer to in the GraphRAG manifesto, the graph of all the vector chunks. Memory shows up as a graph. I mean, the brain is a graph processing engine in some fashion, with neurons and synapses taking the role of nodes and relationships. And then you can algorithmically enhance your graph, such as Google did with PageRank, and then push those ranks back down into the graph, physicalize them, and then use those for ranking, which has become a really common pattern in AI. Here's a process flow talking about what we want to get to with decision traces, where I have a decision, it goes to an agent, you have a system of reasoning. That reasoning can happen in an LLM, it can also happen in a graph. If I left enough time for it, I'll show an architecture example of Uber, who actually have a fully documented process that's instantiated inside of an agentic platform, and where they have a rules graph used to execute these high stakes rules where you can't trust an LLM to do the reasoning, so you do it deterministically using graph multi-hop reasoning. So where are graphs being used to build better AI? We talked about GraphRAG. I just mentioned multi-hop reasoning, but this is basically, if I have the data in the graph, I can just do a connect the dots operation between, for example, an ailment and the 100,000 pharmaceutical compounds that a pharma company will have in its database, and through that connect the dots operation, do solve for medicine using Kevin Bacon, degrees of Kevin Bacon. You can use it to bring together the silos using an enterprise mappings of an enterprise data lake and semantic mapping. We talked about decision traces, and then we talked about memory. So these are the key ways that graphs are being used to build better AI. I'm going to go fast because we're running out of time, but context more colloquially is let's pull the thread on the thing that I'm dealing with, the actor, and just go several levels out. This has incredible predictive value, reduces hallucinations, gives you better accuracy and explainability. Here's an example. I won't go through this just for time, but this one is in the GraphRAG manifesto, vector versus GraphRAG. It also gives you a shared world model where an agent can reason using a graph, but people can understand it. So this is bridging the world of human and machine. And then, if I can see the data, I can apply data access control, so it can help with privacy and trust. There are numerous kinds of graph computation, and I invite you to learn more about these offline. But the first one is this connect the dots kind of stuff. In a proper graph database, you can do about 2 million of these pointer chasing operations per compute core per second. So just spider through the data. Graph algorithms like Google with PageRank. Similarity in search, just like vector databases or search engines. GNNs, which is another kind of vector which says, what's the shape of the data around this node, and look for similar topologies. And then also being able to visualize your data. Using GraphRAG reduces the need for tokens. So token maxing is great for learning, maybe as a short-term incentive to get people developing with AI, but token minimizing is the name of the game once you're in production, as well as results maximization. Gartner is recommending that leaders rethink the central brain for AI agents with an architecture that effectively looks like this. And then here you can see a drill down into the different kinds of graphs in your knowledge layer, ontologies, data, memory, used by agents to provide a semantic layer and relational context. So we're out of time. I'll just wrap by saying, find your graph. Looking at your enterprise is a good way to start. You have all this data in the enterprise, which naturally shows up as a graph. And then last but not least, we put together a page for you where you can find learning resources and how to get started and do more. So thanks.